In this video, we're going to look at a key principle of lighting. How does a computer calculate the apparent illumination of a surface? Here we have a quad, and it is going to be illuminated by this directional light. And this blue line represents a ray that is perpendicular to the surface. That is, this blue line is a line that is perpendicular at 90 degrees to the surface. We call this blue line the normal. The light that reflects off a surface is proportional to the cosine of the angle between the light and the normal. When the light is at 90 degrees to the normal, the cosine of the angle is 0 and we get no illumination. When the light is parallel to the normal, the angle will be 0 and the cosine will be 1, and we will get full illumination. In this scene I have two lights. This light here is red and this light over here is green. If I rotate the surface as opposed to rotating the light, you can see that the surface darkens because less light is reflecting off the surface. And if I get this to 90 degrees, you can see that no light is going to hit this surface. If we come over here, you can see that this surface is green and this surface is red, and if I rotate the object, what happens is this surface here gets some red light and some green light, and so it goes yellow, and you'll see that this surface will get darker. And then as we continue to rotate, this surface will go green and the surface underneath will go dark. I've used an edit normals modifier to expose the direction of the normals. So the first thing you might notice is that the normal information is actually stored on the vertex and not on the surface, as you would probably expect. The reason for this is that it allows a change in the apparent lighting across a surface. I can select these normals. At the moment, the vertex is pointing perpendicular to the surface. And if I rotate the normal, you can see that the lighting on the surface will change as it had done when I actually rotated the entire surface. So here we are getting the full red light. If I rotate it so that it's off to the left, you can see that we get no light because the normals are perpendicular to the light. So the normals are pointing off in this direction, but the light is coming down in this direction. So this surface gets no illumination. And then if I point it off to the right, you can see that the surface will go yellow and then green. So here at this point we are getting some of the red light and some of the green light. Then if I continue to rotate the normals, you can see that now this surface is getting full green light and no red light. You might infer that here we have two vertices. We have a vertex with a normal that points straight up and a vertex with a normal that points off to the right. And in some 3D systems that would be correct. In fact, I believe that Blender splits the vertices in order to represent the normal directions. But in 3ds Max, you can have a single vertex with multiple normals. And we can see this if we switch over to Edit Poly. So this here is actually a single vertex. And if I click and try and move it, you can see that it's a single continuous surface. If I select these two normals that are on the left here and I rotate them, then you can see that what's happening is for these vertices the lighting is being calculated. The surface is dark because it's perpendicular. Yet over here, these vertices, their normal is parallel to the light, so it is fully illuminated. So we get a graduation of the lighting change across this surface, and this is how we represent curved surfaces. Let's just rotate these back so they're perpendicular to the surface. If I come over to the right, what if I rotate these vertices so that they then line up with the vertices on the green surface? So I'm going to rotate them. It is now parallel to the green light. We now get a blend from red light to green light.